In this video we'll show you how we can read in that DXF file of the selector drum and then wrap it around a bar on the A-axis. So right, I'm in the CAD system now, so if I say import a drawing, that's the one and it's in millimeters, so that's the DXF drawing. So we need to set up a 0 position before we export the contours, and if this is the sort of development of the bar, I guess the 0 is going to be at the end of the bar halfway along there. So if I set my datum, if I use midpoint snap, okay, so that will be the datum, and then we simply create the contours as though we were just milling it on a flat surface. So we'll have a contour here, whatever depth we want. Okay, so that's that contour, and then we'll do another one here, make that 5mm. Okay, if it comes to a decision point, okay, there, and then we do the same thing on this one over here. Okay, and we can also drill a hole as well. There's no it's exactly the same, everything is the same for milling, as though everything was happening on the flat face, but of course it's going to be wrapped around a bar, and I'll show you how that works. So if I save that away, okay, and call that AM. Right, so we go into the milling software. So essentially this has got the same interface as the turning software. We can see the 3 contours that we've got, and datum point is the far left of the bar. So the first thing we'll do is to define a tool. I'm not sure how wide they are, I think they're 6mm wide. So if we have a tool of say 5mm, pardon me, 5mm wide, and then we'll set the spindle speed and feed rates, and then we do a go round operation. So if we choose that contour, and then we set up that we want a very small approach, maybe 0.5mm, and a small runoff of 0.5mm. And that should do that, and offset the tool to the right. So what's going to be happening there is that's the tool coming in, so that the material is to the left of the component all the way around, so it's doing a contouring operation rather than just a slot. Now if we wanted to cut on the opposite side, or sorry, the opposite way around, we would just reverse the direction and offset the tool to the left, so that the material is to the right of the tool. So we're maintaining the same cutting conditions all the way around there, so you're not going to get any tool deflection. Okay, so that's done that, and now we simply apply that. So if I edit that go round operation, one of the options is to machine all contours with the same group number, so then that will machine all 3 contours the same. Now we set up a chamfer tool. Again, we give it a diameter, give it a length, and give it a cut depth. So that's the chamfer tool there. Set the spindle speed and feed rate for that tool, and then we use the chamfering operation, and we'll give it a depth, maybe 0.5mm will do. The approach and runoff, if you don't want those, which you normally don't on chamfering, and again machine all contours with the same group number, and we're cutting to the right of that. Okay, so that produces that. Now in the normal course of events we would simply post-process that and would get a flat development, but we want to wrap that around a bar, so there's a couple of things that we need to do. We first of all need to switch on the rotary axis, so we do that here. and we enable it, and the radius value is the radius of the bar, so that's 16 millimeters. Now that command needs to go at the top of the file there, and for that we need a corresponding disable command. So now that we're looking at going around a bar, on the contouring operation we need to set the work surface as the radius of the bar, and we do the same thing on the chamfering operation. So as far as that goes, that will machine that round the bar. But what we can also do is we can get it to show us the stock. So if we just insert a command, now at the moment we have to create an STL file of the bar, but when we have this in the release state, which will be shortly, then it'll just prompt us for the bar diameter and it'll create the STL file on the fly. So we go into the simulator, it prompts us to call up the STL file, which I've already created. So I think this was 32mm diameter, if I read the drawing correctly. So go into the simulator, calls up the bar stock, and the machine's all the way around there. Now we could speed up and slow down the display. And then here comes the chamfering tool. So the nice thing about the way that we work on the rotary axis is, as far as the programming of it concerned, everything that's available to you for the standard milling operations, such as area clearance, contouring, drilling, chamfering, all of those sorts of things, they're all available to you on the rotary axis. All that happens is that the post-processing software, which is the clever part, just wraps it all around a bar. So that's it. That's how we do that.